Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0096, indicates a problem with the intake air temperature, IAT, sensor 2 circuit in the Honda Civic 2022 and newer models. The IAT sensor plays a crucial role in measuring the temperature of the air entering the engine, which helps the powertrain control module, PCM, determine the optimal fuel-to-air mixture for combustion. When the intake air temperature exceeds a specified value, the PCM recognizes this anomaly and stores the DTC, signaling that the normal operating parameters are not being met. This could lead to performance issues, increased emissions, or engine damage if not addressed. It's essential to follow a systematic troubleshooting approach to identify the root cause and rectify it to ensure optimal engine performance and longevity. The IAT Sensor 2 is located in the intake system of the Honda Civic, specifically designed to monitor the temperature of the air entering the engine. Its primary role is to provide the PCM with accurate temperature readings, which are essential for adjusting fuel injection and ignition timing. This sensor ensures that the engine operates efficiently by adapting to varying temperatures of incoming air. A malfunction can lead to incorrect temperature readings, affecting the performance and emissions of the vehicle. The PCM, or Powertrain Control Module, is the brain of the engine control system, interpreting signals from various sensors, including the IAT sensor, to optimize engine performance. Miscommunication between these components due to a malfunctioning IAT Sensor 2 can trigger the P0096 code and result in engine performance issues. Several issues could trigger the DTC P0096. A faulty IAT Sensor 2 is a primary culprit, which may not provide accurate temperature readings due to internal defects or wear over time. Loose connections at the sensor or related components can also disrupt the signal, leading to performance issues as well as triggering the DTC. Additionally, damaged wiring in the circuit can create resistance or open circuits, preventing reliable communication between the IAT sensor and the PCM. It is essential to examine the entire circuit to ensure that no physical damage occurs, as even minor frays or splits may also result in poor readings and an illuminated check engine light. Furthermore, environmental factors or exposure to extreme temperatures might also degrade the sensor's functionality over time. When the DTC P0096 is triggered, several symptoms can become evident. One common sign is the illumination of the check engine light, CEL, on the dashboard, alerting the driver to a potential problem with the engine management system. Poor engine performance may also arise, including rough idling, hesitation during acceleration, or reduced power output. This deterioration in performance often ties back to incorrect air-fuel mixture ratios due to faulty temperature readings. Additionally, drivers may notice a drop in fuel efficiency as the engine struggles to maintain the optimal combustion conditions without accurate input from the IAT sensor. Continual operation with this fault can lead to further complications, requiring more significant repairs down the line. The first step in troubleshooting the DTC P0096 involves bringing the vehicle to the on mode without starting the engine. This action allows the PCM to wake up and begin checking sensor inputs. The next important procedure is to meticulously examine all related connectors for secure connections and inspect them for any loose terminals. Poor connections can often lead to erroneous readings from the IAT sensor, making this inspection a crucial first step in the diagnostic process. This includes looking closely at connectors not just for the IAT Sensor 2, but also for the engine coolant temperature ECT, sensor 1, ECT sensor 2, and mass airflow MAF sensor/IAT sensor 1. Ensuring that all connectors are properly seated can often rectify the issue before moving on to further inspections. In this step, assess the normal conditions at the connections and terminals of the various sensors. If everything checks out and the connections appear secure, this generally indicates no abnormal issues present at this stage in the diagnostic process. However, if inconsistencies arise or if anything seems abnormal, this may pinpoint further issues related to the IAT sensor's functionality or its circuitry. A systematic approach must be employed, looking for signs of corrosion, wear, or other physical defects. Ensuring the integrity of these connections is crucial for the vehicle's PCM to receive and interpret the correct signals from the IAT sensor and associated components. It is also essential to refer back to the diagnostic data for any additional insights. Preparation for a thorough inspection of the IAT sensor 2 is key to diagnosing the issue at hand. First, the sensor must be removed from its position in the intake system. This is followed by allowing the IAT sensor 2 to acclimatize to the ambient temperature in the workshop or garage. Accurate assessments during this step are essential to ensure that both the sensor and the surrounding conditions can be evaluated correctly. Accurate readings at this stage provide fundamental data that can either confirm or negate sensor functionality. Making note of the ambient temperature during this phase is important, as this will serve as the benchmark for comparison when the sensor is connected again for testing. In the next phase of the troubleshooting procedure, reconnect the IAT sensor 2 using its 2P connector without reinstalling the sensor in its housing. This initial connection allows for real-time data to be evaluated. After performing this connection, turn the vehicle to the on mode again to activate the PCM's monitoring capabilities. The Honda Diagnostic System, HDS, should now be accessed to note the value displayed for the IAT sensor 2. This value needs to be closely monitored and compared with the previously noted ambient temperature. The goal during this step is to determine whether the difference meets the specified criteria of less than 5.4 degrees Fahrenheit, 3 degrees Celsius. Any significant difference will affirm that there is an issue with the sensor itself. Having moved through the necessary preparatory steps, the next phase involves simulating high temperatures to further evaluate the IAT sensor 2. First, connect the sensor using its 2P connector, ensuring it remains removed from its housing for safety. Using a heat gun, carefully apply heat to the sensor for a few seconds, being cautious to avoid overheating, which could lead to sensor damage. After heating, quickly confirm the displayed value for IAT sensor 2 on the HDS. For a correctly functioning sensor, this value should exceed 76 Fahrenheit, 42 degrees Celsius. This step is paramount in confirming the sensor's responsiveness under different temperature conditions, thereby establishing its operational viability. Upon completion of the diagnostic and repair process, it's essential to verify that the repair was successful. Start by clearing the DTC from the PCM using the HDS. This step resets the system, allowing for fresh monitoring of any reoccurring issues. After that, taking the vehicle for a test drive is vital to assess whether the issue persists or if the DTC reappears. Keep an eye on the dashboard for the check engine light and monitor the vehicle's behavior during various driving conditions. Successfully completing this step means that the repairs were effective and the IAT sensor 2 circuit is functioning within expected parameters, ensuring that the engine can perform optimally. Preventive maintenance plays a critical role in avoiding future occurrences of the DTC P0096 and ensuring the vehicle operates efficiently. Regular inspection of the IAT sensor and associated connections can help catch issues early, allowing for timely repairs without significant performance losses. Additionally, maintaining clean connections can minimize the risk of corrosion and degradation, protecting the integrity of the electrical circuit. Periodically checking the health of wiring associated with the IAT sensor helps identify potential vulnerabilities before they lead to serious problems. Keeping these components in good condition not only aids in preventing DTCs, but helps in extending the overall lifespan of the vehicle. In conclusion, understanding the role and functionality of components like the IAT Sensor 2 is crucial for effective troubleshooting when faced with DTC P0096. Following systematic inspection procedures not only helps in accurately identifying issues, but can also prevent costly repairs down the road. Regular maintenance, as highlighted, will further ensure the longevity and optimal performance of the vehicle. Staying proactive with inspections and understanding potential symptoms can keep your Honda Civic running smoothly, thus enhancing reliability and peace of mind while you drive. Ultimately, maintaining a routine with preventive actions is your best defense against unexpected engine performance problems. Please like and subscribe to the channel. See you next time.